Periodic classification of elements. It is also known as another chapter name called periodic table and periodic trends of the periodic properties. So whether you're from ICSE background or CBSE background, if you are in class 10, you will have this chapter. Even if you are learning in grade 11 or grade 12, these are the basics you need. Okay, then let's start. My name is Mahantesh Shetter and you're watching Chemistry channel. First of all, why the hell we need to classify elements? What is the reason? Correct. I will give you simple examples to understand this concept. See, when you see this picture, you want to find periodic table chart from this pile of books. What is the probability that you will get that? Even if you get that, how much effort you have to put to find it? Correct? Because these are not properly segregated. The same thing if you want to find that periodic table chart in this where everything is classified and labeled properly, science fiction, literature, novels, etc. So you will go to the science section, you will find the periodic table chart. Very simple. So what the classification made here, it made our work easy. Let's see one more example. Left hand side you check pile of garbage, waste, not at all segregated. Right hand side you check different dustbins with different colors and different labels arranged properly. And if you want to throw a particular waste, you have to throw in that particular dustbin only. So you are at the basic level only segregating the waste, which will help us to process it later easily. One more example shall I give you? Check this out. Say one of the wire is coming from this pole, light pole to your house, and there is some electrical problem. So if you want to replace that wire, how do you find your wire from this? Very difficult. Right hand side you check. This is called electrical engineering work. How neatly everything, all the electrical things are underground, and you will find it easily because they will label everything. Right? So classification of anything will make our work easy. So why the hell we need to classify elements? So what happened towards the end of the 18th and the beginning of 19th centuries, more and more elements began to be discovered, and those elements will have different properties and they will form the compounds which also have different properties. Again, soon the need arose for classifying them. Why? Because we want to do the comparative study. How many compounds you will study, right? So to make our work easy, we need to study them. We need to classify them. Then, on what basis? One is similar chemical properties. One more, the scientists were searching for the characteristic of an element that would never change. Okay. What is that characteristic of an element that would never change? At that time was given by William Prout, and it was atomic mass or atomic weight. That is for given element that will never change. So they started using atomic mass or atomic weight as a tool. Okay. Now, what are Dobereiner's triads? So Dobereiner is the first person who attempted to classify the elements. Okay. Triad. You might have watched, tri means what? Three. You might have watched Three Idiots. Group of three friends is always great. So here, the group of three elements. How he is taking three elements which have similar chemical properties. So those group of three elements, he called it as triad. So he made some three groups, three triads of lithium, sodium, potassium, one group, calcium, strontium, barium, another group, chlorine, bromine, iodine, one more group. Next, what he said, the elements in a triad are arranged in increasing order of their atomic masses. Obviously, you can see here 6.9, 23, 39.1, increasing order. For this also increasing order. For this also increasing order. One more point he gave, very important one. The atomic mass of the middle element of a triad was approximately equal. See, this is first element, this is third element. Middle elements are these. So approximately equal to the mean of the atomic masses of other two elements of that triad. Mean means you take lithium atomic mass 6.9 plus potassium atomic mass 39.1 divided by 2. You should get the atomic mass of sodium. So when you do that, you will actually get the 23.0 as the mean, which is correct. But when you check for the second triad, you will get 88.7. That's why he said approximately equal, not exactly equal. Exact value is 87.6, but you are getting 88.7. Fine, approximately. Again, for third one, bromine, when you calculate from chlorine and iodine divided by 2, you will get 81.2, which is actually should be 80. So this is approximately equal. Okay, these are all things he gave, but sir, why we are not using Dobereiner's triad today, right? The reason for throwing out law of triad. Why we throw out law of triad? First of all, Dobereiner could not arrange all the then known elements in the form of triads. Assume that there were some 30 elements at that time. He made only groups 3 triads or 4 triads. Okay. What about remaining elements? Correct. If you're classifying, you should classify all the elements should be there. This is the biggest drawback. And also, the law did not fully apply even within the same family. Which law? The atomic mass, average atomic mass. Okay, say for example, you take the halogen family, fluorine, chlorine, bromine. Chlorine, bromine, iodine he did. If you take fluorine, chlorine, bromine, you should get the atomic mass of 35.5 for chlorine when you get the arithmetic mean of fluorine and bromine atomic masses. So what you do, you will get when you do, you will get 49.5, not 35.5, which is not at all approximately equal. A large difference is there. So these are the reasons why the law of triad is not used today. Okay. Next, question time. Let's check what you understood from this. Okay. First question. What is the need for classification of elements? Right? Already I told you that to make comparative study of elements easier. To make comparative study of elements easier. What was the basis of the earliest attempts made for classification and grouping of elements? Basis. There are 2 points. One is similar chemical properties, another one is atomic mass. Why were Dobereiner's triad discarded? In the previous slide, we discussed the 2 points. You can go back and check that. A, B, C are the elements of a Dobereiner's triad. If the atomic mass of A is 7, C is 39, what should be atomic mass of B? Simple arithmetic mean, you take 7 plus 39 divided by 2, you will get 23. So atomic mass of B should be 23. Lithium, sodium, potassium elements were put in one group on the basis of their similar properties. What are those similar properties? First of all, lithium, sodium, potassium, all are metals, all have valency 1, all form oxides which are alkaline. Oxides, alkaline means when you dissolve them in water, they are soluble. Similarly, calcium, strontium, barium, why you are or what are those similar properties? You are grouping them together. Again, valency is 2, all metals, all form oxides which are alkaline. So these are the things, questions to understand your concepts. So in the next session, we'll learn about the Newland's law of octave and Mendeleev's periodic table. Until then, take care. Bye bye.